Hello students, this is kind of a review or a brief discussion before we try to attempt homework number one, or before you try to attempt homework number one. I would like to first go over the table for the Laplace transform. If you see a unit step function like you see item number 2, the Laplace of that is always going to be 1 over s. Okay, if you see, this is called the unit step. Okay, so the Laplace for the unit step is 1 over s. And you're also sometimes most probably going to use the impulse function. If it is delta t, this is called the impulse. And the Laplace of impulse is nothing but simply 1, like you can see in the table. So this is a unique table. You are going to be using this table a lot. The Laplace transform of t u of t is 1 over s squared, keeping in mind u of t is a unit step function. So same way, if you have t to the power of n, so let's say if n was equal to 2, this will become 2 factorial over 2 plus 1. So 2 factorial over s cubed. And I think you kind of remember this. Factorial will be 2 factorial will be 2 times 1. So 2 times 1 divided by s cubed. Similarly, take a look at this one, number 5. You're going to be using this a lot. E to the power of negative at u of t. The Laplace transformation, sometimes the symbol we use like this. Okay, this is called Laplace transformation of this time domain function. If you take the Laplace, we'll go to the s domain, and that will be equal to 1 over s plus a. So example, if this is equal to negative 2t, then the Laplace transformation in s domain will simply be equal to 1 over s plus 2. So you're going to be using this a lot, okay? And then you have trigonometric function like the sine is going to be sine of omega t is omega over s square plus omega square. Cosine of omega t is equal to s over s plus omega square. So this table, keep it handy with you while you're trying to solve the problems. Another table that you are going to be needing for homework number 1 is the items from basically 7 through 9. So if you take the Laplace of df by dt, then in s domain that's simply equal to s times f of s minus f of 0. These are called the initial conditions. So you will use these three, and later on we're going to look at 11 and 12. But for right now, for homework number 1, 7, 8, and 9 will do, and this table on the left hand side. Now coming down to the bottom one, okay. In the bottom one, what we are trying to say here, I try to move the screen up so clear up that area for you. So if you will, if you have a capacitor, okay, you know a capacitor is a storage device. If you have a capacitor, you recall that the symbol of the capacitor looks like this. And if you want to find out the current through the capacitor, that's simply equal to I of t c dv of d by dt. Okay. Now you take the Laplace, try to convert this capacitance and replace it in terms of impedance. So the impedance in terms of s domain will be 1 over cs. Okay. So keep in mind this is called the impedance. Impedance. So the impedance for the capacitor is 1 over cs. Now obviously the admittance, as you recall from your previous discussions and studies that you did, admittance is just the opposite of impedance. But however, the impedance is voltage in time domain here, so this is S, and frequency domain, which is S domain, divided by the I of S is always equal to the impedance. So impedance is equal to 1 over Cs. So admittance is just the opposite of impedance. So Y of S will be 1 over Zs, which makes this Is over Vs. You get it, guys? So obviously this is going to be flipped over. This will be CFS. So if a circuit comes in and you want to convert a capacitive circuit into the time domain, if you're looking at the impedance, you're going to write 1 over Cs. Okay. And a neat thing about the resistance, nothing changes, you know. It's not a function of what you call T in here. Is the resistor is just equal to R in the S domain also. And obviously, opposite of that is called the conductance, which is G. G is equal to 1 over R. And the last but not the least component is called the inductor. And the inductor, as you know, is L is the symbol. Inductance is measured in Henry. But if you write it in terms of the impedance, the inductance in the circuit will just be replaced by SL. So the admittance, like we said before, is the reciprocal of the impedance, so that's going to be 1 over SL. Okay, so I will see you in the next video shortly.